welcome back to this channel. We'll continue our studies on signals and systems. So today I'll be talking about operations on signals. And we have basically three operations on signals. We have time flipping, time shifting, and time scaling. What is time flipping? Time flipping is simply when I actually move a signal when I do a mirror. When I mirror a signal, that's actually what time flipping is. And time shifting is when I actually move, is either I advance the signal or I actually delay the signal. And time scaling is all about I increase the signal, I increase the time of the signal by, let's say, k. So here I have a problem here which I'm going to be solving for this, which is going to illustrate time flipping, time shifting, and time scaling. Now, this problem is actually a very simple problem. For x of t drawn below, we are asked to sketch the following signal, x minus t. Now, when you hear time flipping simply means whenever you see something like this, x, you have an original signal, say x of t, or an original signal, say y of t. Now, if you want to do time flipping, what you do is x minus t. Minus here is telling you you should do a time flipping of what? Of the original signal x of t. And if you also see this y minus t, it simply means do a time flipping of what? Of the original signal, say y of t. Now, in this question now, sketch the following x of minus t. You know, I told you time flipping actually deals with what? With mirroring the signal. If I have to place a mirror here and I have to mirror this signal, that simply means that I will draw this signal, the new signal I'm going to be generating is going to look like this. It's going to start here, let's say this is 3, and here we have, then we can now have the rest here, and here we have our 0, and so it will continue like this, minus 3. So now I have just created a time flipping of what? Of this original signal. So this is x of minus t, and here is what? X of t. So anytime you are asked to do time flipping, whenever you see x of minus t, what this is actually saying, what this is actually telling you is what? You should do a time flipping of the original signal. What you have to do is imagine placing a mirror here. Now the image that will be formed by the mirror is what you draw as your what? As your time flipping. So we move to the next one, which is Roman figure 2. I'm going to do this in stages. This is talking about what? Time shifting. X t plus 2. Now, let me quickly say this. Most people get confused when it comes to signal because what you see, when you see plus, when people see plus, they thought, okay, maybe I'm going to be adding or something. But in signal, when you see plus, it actually means that I am advancing. That means that signal is actually advancing. When you see minus, it actually means that that signal is delaying. Let me explain what advancing and let me explain what delaying is. Now, when you say a signal x of t is advancing, a signal x of t advances when we have, let's say, this is x of t. Let me use an impulse let me use a step function, an if-side function to explain this. Now, and this is originally an if-side function u of t. Now, if I want to advance this u of t by 1, what I do is if I want to advance u of t by 1, I will write u of t plus 1. That means u of t is advancing. So by the time I want to draw this, I'm going to draw this like this. It is starting from what? Minus 1. So as against what you see here, which is what? Plus 1. When you see this, is actually talking about what? This is advancing. This signal u of t is advancing, which is what? At minus 1. Now, in the same way, if I want to find u bracket t minus 1, this is actually telling you I have actually delayed u of t by what? By 1 second or 1 period. It simply means I'm going to draw this like this, and I'm going to come to this place after 0 axis to the positive side. Then I'm going to write 0, then I'm going to write 1. This is u into bracket t minus 1. I think this is just like a prelude to how we are going to solve this. By now it should be easier, and it should have been clear to you how we are going to draw this xt plus 2. Now to the question xt plus 2. Now this is the original signal. that means I am going to be what? I am going to be advancing x of t by what? By 2 period or 2 seconds. You may say 2 seconds, you may say 2 period, it might be a period, it might be in terms of just ordinary time. Now, you draw this by doing this. I don't have to flip. All I just have to draw is simple. Draw this. Then the next step is you quickly move this. This is going to be like this. Since I'm delaying it by 2, that means these 2, I'll subtract 2 from these 3. This is the original signal ends at what? 3 seconds or 3 period. So I remove 2 from here, that means I'm having 1. So where my drawing is going to end will be 1 here. Then I'm going to start, since I have 0 here, then what I'm going to do to this is what? I'm going to start from -2. So I start like this. Then I go to this. So this is -2, this is 1. You can see the difference between this and this is still going to be what? It's still going to be 3, like the former signal. But the only thing I've just done is that I have actually advanced the signal. Is that understood? Let me recap again. Advancing a signal simply means you are moving backward. While delaying a signal simply means you are moving it forward on the x-axis. Now we are moving to problem 3. In problem 3, we have about 2 operations embedded in problem 3. Number 1, we have time shifting, which is standing for what? Plus 2, and we have time scaling, which is standing for what? 2t. That is 2 multiplied by t. Now let me quickly tell you this. What is all about time? What is all about what? Time scaling. Now in time scaling we have one thing. We have expansion and we have compression. Now, let's say we have x of t as we have here. Then when I write xkt, what this k is actually standing for is what? Is actually telling me time scaling. Now, when my k is greater than 1, what I'm actually doing is what? Is compression. When my k is less than 1, what I'm actually doing is expansion. Now, when I want to draw when k is less, generally speaking, this is how you go about interpreting SKT, which is your time scaling. You go about it. Let's say we are working with this signal. Then we have something like this. Then we have something like this. Now, this is going to be 0 divided by k, whatever k is, either it is greater than 1 or less than 1, and 3 divided by what? By k. Now, let's move on to the real question that we have the real problem that we have to solve, which is 2t plus 2. Now, 2t plus 2, let me quickly give you a thumb rule here. There is a thumb rule when you work as a beginner when you want to start sketching signal. Do this first. Number 1, flip before you shift, before you scale. So that is flipping operation before shifting operation and before scaling operation. Now, let me do this. Now, I have 2t plus 2. The shifting part here is what? The shifting part here in this signal is my what? Is my plus 2. So what I'm going to do is draw this. Then I have what? I have 0 and 3 here as the point of my t for my main signal. What I'm going to do with plus 2 is this. I'm going to subtract 2 from here, which is going to leave this place as what? As 1. That is, I'm going to move this to 1. So I'm going to have 1 here. Then I'm going to subtract the same 2 from here, which is going to be 0 minus 2. That's what? That's minus 2. So let me put another point minus 2 here. Then from here, I can now draw my signal. My signal is just going to look the same way, but now at different points. Now I have just done x of, let me say, arbitrarily, let's say p plus 2. Here that p is our 2t. That is, all I've just done is what? I have shifted the operation. Because I have 2 operations here, shifting and scaling. So next step is, I will come back to what? I will come back to this p. My p here, where p, let me write this, where my p is equals to what? 2t. Next step here is what? My p is what? 2t. I have to do this operation, which is time scaling. And I told you that when you have k greater than 1, you have what? You have compression. So all I want to do right now is what? I want to compress this signal. So compressing this signal, later on in this course, we will learn about what we call sampling, oversampling, downsampling. Now, what I'm doing here, which you may see as what? P is equals to 2T, which is actually talking about compression, is actually talking about me doing what? Downsampling. So it's talking about I'm going to divide these points on the t-axis. I'm going to divide it by what? By 2. So hence, if I divide this one, if I divide minus 2 by 2, I have what? Minus 1. So the original signal itself is going to look like this. I have minus 1 here. I have point 0 here. This is 0. Then I'm going to have another point 1 over 2. Hence, I'm going to draw it. I'm going to draw everything to look like this. So hence, I have actually compressed this signal. So this is now x into bracket 2t plus 2. Now, welcome back. Now to problem 3. Problem 3, I'm going to be solving x into bracket 1 minus 3t. How you approach this kind of problem is very, very simple. Remember, you did algebra, right? Good. So what you do here is you will do something like this for me. X, open bracket. Now, bring out minus 1 out. Then you have what? Then you have 3t minus 1. The whole signal that is x into bracket 1 minus 3t is now x into bracket minus 1, 3t minus 1. What this minus 1 is trying to tell you is you are going to flip first, then later you will shift, then later you will scale. I've given you a thumb rule. Whenever you want to draw a signal, what you do first is what? Number 1, flip. As a beginner, you flip first. Then you followed it up by what? By shifting. Then you finally do what? Time scaling. Provided those 3 operations are present in that very signal. Now, let's go back. Let's go and do this. That means I have to do what? I have to flip this signal. I have to flip this original signal. If I flip this signal, what I'm going to have is, where I have 3, I'm going to have what? Minus 3. Now, here where I have 0, I'm going to have 0. Since you know that 0 multiplied by negative is still minus 1. Multiplied by minus 1 is still what? 0. So this is what I'm going to do. I'm going to have minus 3 here. Then I'm going to have 0.0 here. So where this is now going to be like this. And I have told you that whenever you want to flip, flipping operation is like carrying a mirror beside your signal. Then the image produced by your mirror, taking your original signal as your object, the image produced by your mirror is actually your what? Your time flipping operation, or we call it time reversal. So look at this. We have something like this. Then we have this. Then we have something like this. Then we have this. So here I have minus 3 and 0. I already have this. I have done what? Time reversal, which is time flipping. Next, I need to do what? I need to do time shifting. In this case, this time shifting is actually what? Is actually delaying. So if this is actually delaying, that means I need to add 1 to this and add 1 to this. So if I add 1 to this is going to be what? Minus 2. Minus 3 plus 1 is going to be what? Minus 2. 0 plus 1 is going to be what? 1. So I need to have another point here that I'm going to draw here, and I'm going to say I have what? 1. I have 1, then I have minus 2. So let me draw the same signal again. I'm going to have the same signal, then I'm going to have the same signal come like this. Sorry, let me use this marker so that it can be very legible for everyone to see. It's not going to be like this, and I have this. So here I have done what? I have done the second, I have done this, I have done this, which is what? Time reversal. I have done time shifting. Lastly, I'm going to do what? Time scaling. Since my k that is standing here, if you remember the first problem, since my k that is standing here is greater than 1, this is going to be that I'm going to divide this point by what? By 3. Hence, the whole thing is now going, I'm going to draw the final diagram as this. The final diagram is going to look very simple, or the final diagram can, let me just put it this way. In a neater form, this is going to be minus 2 divided by 3, then 1 divided by 3, then I draw this and I draw this, and I draw this, and I draw this. Sorry, not very good with drawing, but this is now going to be x into bracket 1 minus 3t. Here is our final signal for is our final drawing for the sketch of what s into bracket 1 minus 3t. Now let me quickly recap before I move on to other things, because after this we are moving on to system. Now, whenever you want to sketch any signal, be it continuous time signal, discrete time signal. I know everything I've just done is on continuous time signal. I'll give 2 examples more on discrete time signal, and I will leave you with a miscellaneous question. So, that miscellaneous question, maybe I'll solve it, maybe I will not, maybe you guys should get an answer to that by yourself. But let me quickly tell you this. The thumb rule of drawing signal for a beginner is number 1, flip. If flipping is present in that operation. Number 2, shift. If shifting is present in that operation. And remember that our shifting is divided into 2. It's either I am doing time delaying or I'm doing time advancing. Now, number 3, you do time scaling, which is also divided into 2. It's either I am compressing or I'm expanding the signal. So here we'll move on to what? Sketching discrete time signal. Okay, now I think if you've been following this video to this point, this is the time where I will ask you to comment, like, subscribe to this channel so that you can know when we post new videos, when we update you about signals and system. Anyway, now what I will say is this: whatever you feel, just say something in the comment section. Say something about the teacher, say something about the channel, say something about the aesthetics of even the channel itself. I'm open to any kind of comment. Thank you very much. Now let's go to discrete time signal. How do we solve this? Now, the example I gave the other time were all based on what? On continuous time signal, CT. This is now discrete time signal. Now, here we have, these are impulses, but here we have half of impulse, half of a direct delta impulse here. Now, from -1 to 3, we have an impulse. Then at 4, we have half of the impulse. We have a short impulse. Now, we want to do xn minus 2. What xn and minus 2 is actually talking to you, is actually saying is what? Is actually communicating to you that we are actually going to be doing what? Time shifting. So, by -2, what this is actually telling you is that I am going to shift this whole signal to the right. Because this is actually going to be what? This is actually going to be delaying the signal. So I'm going to delay this signal by 2. To delay this signal by 2, I have my signal starting from -1 here. Add +2 to it. That means that's what? 1. That means I'm going to be starting the drawing of this signal from what? From 1. Then the last signal I have here is what? Is 4. Add 2 to it, we have what? 6. That means this last signal here will be appearing as what? N is equals to 6. Now let me draw. Let's get to work. Now this is now going to be this is going to be starting from 1. Let's say this is 0, so let me just put this is 0, so let me put this to show you this is 0. Then 1, 2, 3, 4, 5, and 6. So here by -2, if I shift it by -2, so I will start from 1. Since I'm starting from 1, 1, then when I get to 6, because what is at 4 in the original signal will be appearing at what? At 6 here now. So it's going to be like this. So I have this to be 1, and I have this to be 1/2. I am done with what? X common bracket n minus 2. This is going to be your discrete time signal for xn minus 2. Now let's get to this is I have solved 1. Now let's get to x into bracket 4 minus n. What is here looking at this is going to be, see, it is not uncommon to find a signal where n is not leading first. Whenever you find a signal where n or t is not leading first, that means in that signal, embedded in that signal, is a time reversal operation. So now look at this. I will rewrite this. I will first rewrite this as though I have x into bracket 4 minus n. To make n comes first, just like it's coming first in this first part of the problem, I'm going to do this which is going to be equals to x into bracket minus 1 bracket n minus 4 close bracket. Did you see this? Now moving on from this, that means I'm going to do a time reversal. Then later I'm going to do what? I'm going to do a time shifting operation. So there are two operations embedded in this second problem. Now let me do the first operation. The first operation says that I'm going to do what? I'm going to do a mirror of this. I'm going to take a mirror of this. If I take a mirror of this, what this is actually saying is going to be. What this is going to be, this is going to be what? This is going to be at minus 4. And this minus 1, what is at minus 1 will be at what? 1. So I'm going to draw this. Remember, a time reversal operation is just you viewing the signal, putting a mirror behind the signal. The image formed by your signal in the mirror is actually your time reversal operation. Now, look at this. I'm going to draw this again. I'm going to draw this like I have this. I'm going to start here by minus 4, minus 3, minus 2, minus 1, 0, then 1. Now, I am going to draw this. I'm going to have minus. This is going to be whatever is at 4 now will be at minus 4. Then I have this. Then I have this. Then I have this. I have this. Then I have this. The rest are the zeros. Now I have done this operation. This part of the operation. I have done this part of the operation. Can you see? I have done this part of the operation. The next part of the operation is what? Is for me to shift the signal by what? By, let's say, 4. I should shift the signal by 4 to where? To the right, because this is minus. Now, I'm going to add, if I add 4 to this place, what am I going to get? That means I'm going to be getting what? 0. That means this signal should be appearing at 0 at the final point. I should have this at what? At 0. Then I should have this 1. Add 1 to 4. That means I should have this at what? At 5. So right now I'm going to draw the signal. Just watch me as I draw the signal. The final signal is going to be here, and here is going to be our final signal. I have something like this. Then I'm going to be starting from what? Minus 4 plus 4. That's going to be what? 0. So if this is starting from 0, I'll call this place 0. Let me just call this place 0. So I have, let me say, okay, half 1 over 2, half of what? A short dirac. Then I have this. One, 2, 3. This is going to be 1, 2, 3, 4. Then we are going to have another last signal 5. So this is now our what? S4 minus n. This is going to be our S4 minus n. Now, here's the last problem. The last problem is x of 2n. What x of 2n is, by now you should have understood that. What x of 2n is actually telling me is, I'm going to compress this signal. I'm going to compress this signal. Anyway, let me tell you something. A practical, because you might be saying, all these things I'm just doing, what is really, where in electrical engineering is this applied? Whenever you are on a YouTube, I know you are on this channel, this is a YouTube channel, right? Then you remember, if you want to download this very video, you will see you will be given options, provided you are using a very, like a new age phone. You'll be given options like 360p, 720p, and 1080p, then you'll be given HD. Actually, compression, the main video might have been done in HD, but due to compression, I can bring it from HD to the likes of 720p or 108p, 1080p. What I have actually done in that essence is I have actually done this operation, but it may not be 2n that was used. It might be something. It might be another variable that was used. So that is a pretty much an example, or let me say an illustration of what it truly means to compress a signal. So now let's move on. S2n simply means I want to compress a signal. Now let's go on to this. So that simply means I'm going to be dividing this by 2. So you know, if I divide this by 2, If I divide this by 2, if I divide this, I cannot divide. This is a discrete signal. It's not unlike our continuous time signal. In our continuous time signal, we can have our signal at 0.5. If I divide this one by 2, I'm going to have 0.5. And I cannot, in a discrete time signal, I can't have a signal at 0.5. So the best signal I can actually compress here is going to be at 2. So the 2 divided by 2, I have 1. I cannot compress this because this is going to give me 1.5. And n must be a whole number in a discrete time signal. It must not be 1 point, 2 point. That is not allowed in discrete time signal. So the next signal I can also compress is what is at 4. So that's going to be 4 divided by 2. That's going to be what? 2. So let's get on. If I divide this by 2, you sure know that I'm going to get what? 0. So we will still have to keep what? 1/2. But this is the main signal I'm using, right? This is the main signal I'm using. So I'll come here. 0 divided by 2, I have 0. So I'm going to keep this signal. Let me tell you things I'm going to keep. I'm going to keep this signal. So I mark it. I cannot pick this because this is a discrete time signal. So I'll go to 2. I'm going to pick this signal, right? Now this I am going to pick this signal because this is 4. 4 divided by 2, it gave me a whole number which is what? 2. I cannot pick this signal because it's going to give me 1.5. So let's get to the work. This I cannot say I'm picking 1, 2, and 4. And so by the time I'm drawing them, they will not be 1, 2, and 4. They will just be this. This is going to be 0. Then I pick this next, which is going to be what? Which is going to be 1. Then this is now going to be 2. So this is now my what? X to n. So now, oh, sorry, I made a mistake. This is going to be half. So I'm going to do this. I'm going to do 1/2. Let me quickly help some students here. Some students might be thinking, at this point, I ought to divide the amplitude by what? By 2. There is a difference between amplitude scaling and time scaling. If I want to do amplitude scaling for this, I would add what? I will add 2 to the back. Or I might add 1/2 to the back. In amplitude scaling, 2 times x of whatever is still same. Is like I'm adding what? I'm going to multiply it by 2. 1/2 of this is going to be. But in time scaling, it is the opposite. Whenever you see 2 appearing, it actually means you are divided by 2. When you see when you see k dividing that your signal, then that simply means you are actually going to what? You are going to multiply your signal by k. So I think this is the point where I have to recap, and I have to tell you that if you really want to keep enjoying this channel and you don't want to frustrate the person who is actually teaching, don't mind, you can't really frustrate me. But if you really want this channel to continue, please do subscribe, like, comment, say something, at least for an improvement, and please do. And as I have always advised, this video is never an option for you to ditch your class, your lecturer's class, your professor's class for this video. Your lecturers, your professor, they might not be speaking in terms you really understand, but they actually have more to give to you than I can actually give to you. All I'm doing here is explaining in a simple term what they are saying in class. Thank you very much.